Hey guys, welcome to today's video. In this video we are going to understand one more LeetCode question which is called flood fill, and the question number is 733. It comes under easy, and we can call it as a matrix question or a graph question. So let's understand this question first. So the question is saying an image is represented by m cross n integer grid image where image of ij represents the pixel value of the image. So you are given three integers SR, SC and color. You should perform a flood fill on the image starting from the pixel image SR, SC. So SR and SC is the starting indices of the matrix from where we need to start doing the flood fill. Now let's understand what exactly the flood fill is. So to perform a flood fill, consider the starting pixel plus any pixel connected 4 directionally to the starting pixel of the same color as a starting pixel, plus any pixel connected 4 directionally to those pixels and also with the same color, and so on. Replace the color of all the aforementioned pixels with the color. So return the modified image after performing the flood fill. So what exactly it is saying, so you need to do the flood fill starting from the pixel, starting from the indices given. So if in this example they have given the starting index as 1 1, so we need to start from here and we need to go 4 directionally. Okay, so 4 directionally means up, left, right and down. So in these 4 directions we need to go, and if the color, so here it is given as integers, but we can consider it as a color. So the same integer value means it is of same color. So this means 1 is one color and 0 is another color, and this color is with which we need to paint the indices. Okay, so suppose the color is 2, suppose this color is 2 and starting index is 1 and 1. So we need to go 4 directionally, so we need to color this. Why not this and this? Because so it is saying the starting pixel of the same color as the starting pixel. Okay, so you need to be, so if these two are in the same color, if the 4 directional area wherever we are moving, if it is of the same color from where we are moving, then only we should turn this change. Okay, suppose we made it as a 2, now we went up and we make this also as 2. Okay, now we went left, this also as 2. Now since this was not 1, so we cannot change it to 2, so it should be of the same color. Okay, now we change this and this. Now since we have changed this, now we need to go 4 directionally to this, so we need to go this side, so we need to change this part to 2. We need to go the left, we need to change this. We need to go bottom, so bottom is already changed, so we need to go up, and up is nothing. So these two also will get changed and this will also get changed after that. So let me make you understand by whiteboard. So let's understand with this matrix. So this is the same matrix which I have taken. So suppose we are starting from here, so we will change this to 2. Okay, so this color is changed, and now we need to change in the all 4 direction. If this color and the 4 directional color is same, so this is also 1, so I can change this also 2. Now my left side, this is also changed to 2. Now this and this is 0, not 1, so I'm not changing it now. So this 2 has been changed. Okay, now we'll go 4 direction of this. Now we are going to the left first, then we are changing this also to 2, this also to 2. Up is nothing and the bottom one is already changed. Now we go to this. Now we need to change, left side is nothing, right side is already changed, up side is already changed. Now only the bottom part is remaining, so we are changing this also 2. So after this, so this all become 2, this also becomes 2, and this all becomes 2. So this is what it is, right? So after this, the whole row became 2, this 2 became 2, and the last row became 2. Hope you understood this question. So it's a matrix question, and since we need to do a recursive thing, so better to go for any recursive algorithm. So either we can go for BFS or DFS, since we need to traverse all the indexes. So it's better to go for DFS. It will take less amount of code. Okay, so let's write the same code what we have explained here. So we will go to the 4 direction and we will make the changes. Okay, so now first let's get the row length. Okay, so which is nothing but image dot length. So this is my row length. Okay, now I need to have my column length. Okay, which is image of 0 dot length. So if you see in the constraint, so my m and n value, which is like a row and column value, will always be greater than 1. So that's why I'm not checking for null if this will give null pointer exception or not. Okay, so now I have got the row and the column length. Okay, now if my start color is equal to the color I wanted to do, so if it's same, then I don't think so we need to do anything. We can just return the image as it is. So our start color is actually, so int start color is nothing but image of SR and SC is the starting row index and the starting column index. Okay, this is my start color. So if my start color and the color I want to do is the same, so I don't have to do anything. I can just simply return the image. And if I have to do, then what I have to do, recursive color. Okay, so here I can pass my image. Okay, my row, my starting row index, my starting column index, the color I want. Okay, and sorry, and the start color. Okay, so I'll let you know why I'm passing these things, what will be the use of this. Now and now I need to pass my row length, which is not going to change, but it will be helpful for me. I don't have to do again image dot length, image 0 dot length. Okay, after doing the recursive coloring, I can simply return the image. Okay, now we need to define this recursive color function. We can give private void recursive color. So we are taking the image. Okay, int row, int column index. Okay, int start color, int n, int m. Okay, so why do we need start color? Because once we change this, we need to have, once we change the first ones, it will change to 2, right? So or whatever the color it has been given. So once we change this, how we will come to know this is the same as the matching my starting index. So to get to know that, I need to pass my start color, which will not change. Okay, so now I'll just add the base conditions. So what are the base conditions? So my row should be lesser than n. So my base condition is if my row becomes greater than n, or row becomes less than 0, or my columns become greater than the column length, or my column becomes less than 0, or my image of row and column, it's not equal to start color. then I should return, right? So if this is 0 and I don't have to I don't have to proceed after that, right? If this is 0, why I should proceed? I don't have to color after it, right? So I'm returning. So now if these are not the case, then what I'll do, I'll mark my image of row and column. I'll color it with the asked color. Okay, so now I mark the color. Now the easiest thing you need to do, and you can perform this function with any kind of DFS algorithm. So wherever you have the matrix, you need to perform the similar way. Okay, now you just pass the image as it is. Row will become row plus 1, column as it is, start color will remain as it is, your row length and column length become as it is. Okay, now you need to perform this in 4 direction, 2, 3 and 4. So row plus 1, row minus 1. Now row remains the same, so column plus 1 and column minus 1. So why we are doing this? So if I'm here, okay, my 1 and 1, so my row number is here is 0 1 2 0 1 2. Okay, now if my here I'm here, so my row and column is 1 and 1, right? So if I have to move up, so in this case my row number becomes minus 1, right? So it becomes row minus 1 and column remains as it is. If I have to move down, my row number increases, right? It becomes 2, so it is 2 and 1, right? So it becomes plus 1. So if I have to move up, it will become minus 1. If I have to move downward, it becomes plus 1. Similarly for column, if I have to move this side, it becomes plus 1, and if I have to move this side, my column becomes minus 1, right? So we are performing the same thing. Okay, so I'm making column number as it is. I'm doing the plus 1 if I have to move downwards, minus 1 if I have to move upwards, and if I have to move right, then plus 1, and if I have to move left, then minus 1. Okay, actually whatever we spoke in plain English, and so we are writing the code as it is. So let's run this. Okay, so what is the error? Because the solution should be applied to given types. Okay, do I have 1 2 3 4? Okay, we are not passing the color over here, so it should be int color and it should be minus 1. It should be minus 1. Okay, since we are checking equal to and not greater than equal to, so we need to perform the minus 1. I think we should be able to run this. No, okay, sorry. I think before start color we need to add this. So it got passed. Let's try to submit this. So it got submitted. Hope you understood this question. See you in the next. Thank you.